Hello everyone, today we are going to start the new part of our physics part and which is the pressure. So we have already covered the introduction part from this chapter, okay? So we'll revise it quickly. So in this chapter we are going to understand about the pressure, then fluid pressure and application of the pressure. In this chapter we will cover all these points clearly. Okay, so in previous chapter we learned about the effect of force in various situations. Yes, we already gone through that. When we explore the effects of the force a little deeper, okay, we will find that in many situations, okay, it is not just a force but another physical quantity called pressure. Okay, so we have like another physical quantity which is nothing but the result of force, which is nothing but the result of force and which is called as the pressure. It comes into the play. Look at the pictures below and understand the pressure in better manner. So see here the teacher, okay, the teacher going to like pin that particular notice board on like notice on the notice board. So she is applying pressure on that nail, okay, and see means she is applying pressure on the large surface area but it is going to act on the small area, okay, hence the pressure will be more over here, so it is going to insert inside the board and that notice board can be stick easily with the help of that. Okay, next see here that cylinder which is filled with the air at a high pressure, and when it is being blown, okay, or which is being filled inside the balloon, if the air filled inside the balloon above the permissible limit, air applies more pressure on the wall of the balloon and balloon will get burst. Okay, if it is below the permissible limit, so balloon will not going to burst, okay, because here the air which is below the permissible limit. Okay, in next example it is nothing but the flight. Okay, so the design of flight, okay, it is been designed in such a way so that the resistance of the air can be reduced. Okay, so now we will understand the question from here. Which end of the tag pin should be used for pinning up the notice? Okay, so here we have the answer, the sharp end, the sharp end. Second question, why does the balloon burst? We already gone through that. The balloon burst, okay, when too much means more air above the permissible limit is blown into it. That's why it got burst. Fourth, why it is necessary to pressurize the cabin of the high flying airplane? Okay, why it has been pressurized? So this is the question. Okay, so because airplane flies at a very high altitude, at a very high distance from the surface, we can say, okay, and the air pressure is very low there, okay, that's why we had to maintain the surrounding pressure with inside. That's why it is necessary to pressurize the cabin of high flying airplane, because if there is low pressure inside the cabin, okay, then our like vein and arteries are going to burst, is it? That's why we are on the surface and we are like walking it, we are used to that particular pressure, one atmospheric pressure we can say, which has been applied by the atmospheric air. So same air pressure have to be present inside the cabin, okay, because when we go up air pressure decreases, is it? So due to decrease in air pressure, our arteries and veins, they are going to inflate and maybe they can burst. So in order to prevent that, air is being like pressurized in the cabin or inside the airplane so that we can feel normal. Okay, everyone, it is very important concept we gone through from here. Okay, everyone, keep replying.
Okay, sir.
Okay, sir.
Okay,
Okay.
sir.
Yes, sir. Okay. Now next. Okay, so pressure is defined as the force per unit area. The force per unit area is called as pressure. We already gone through that. Hence, we can write the formula force divided by area. Okay, and force has unit Newton and area have meter square. So Newton per meter square. Newton per meter square will be the unit of pressure. The SI unit of pressure, okay, is called as the Pascal, which is Newton per square meter. So Newton per square meter is called as Pascal. Okay. Some very important and useful device such as syringe, dropper, drinking straw work on the principle of the pressure only, and we have already gone through in our introduction part. Okay, so we are going to start the numerical part first. Okay, so here we are going to calculate the pressure. So we have topic here calculating pressure by numericals. Let us see how we calculate the pressure. Example first. If force of 2 Newton, see it is given force is equals to 2 Newton. So it is given part. So we have to write here given F equals to 2 Newton is applied on the area of 2 centimeter square. Okay, 2 centimeter square. It is area. So I'm writing here area equals to 2 centimeter square. See, here we have Newton and the area is in centimeter. So we have to convert that area into meter square. Into meter square because we have unit Newton per meter square, right? So we have to convert that centimeter into meter first. Then we will be able to calculate that. Okay. Okay, everyone.
Okay, sir.
Okay. So see here it has been already been converted here. Okay, so 1 centimeter equals to 10,000. Okay, 10,000 or no 1 meter equals to 10,000 centimeter like this. Okay, so see here we have it has been converted, so we had to divide that centimeter into 10,000. So it will be 2 divided by
Is it
10,000.
supposed to be 100 like 1
No.
Yes,
It
sir,
is
it's 100
millimeter.
centimeters.
supposed to be 100
No,
because 1 meter equal to 100 centimeter.
no, beta. It is
10,000 millimeter, you're
it,
saying?
yeah. No. We have to convert that in meter, na? See here, it has been converted already. It is meter. See,
Yeah, yeah,
do you
sir, but it's
do you
not supposed
have
to be.
scale with you? Scale.
Yes, sir.
Yes,
Here
sir.
we are having millimeter. Okay, here. See, here we have it a millimeter. Mm. Is it
Yes, sir.
millimeter? Yeah. And inside millimeter we are having centimeter. Okay,
Sir,
and we are
isn't it millimeter and centimeter? Like millimeter is the
yes.
one line, sir. Between and that line is centimeter.
Yes. You got the point.
Isn't it the opposite? That's what I'm saying. What
So
is
it is
millimeter is centimeter?
1,000 into 1,000. So 1,000 centimeter equals to no, it is 1,000 into 1,000 will be not 1,000. It is 1,000 into 100, beta. Okay, so 1,000 into 100. See, it is centimeter. It is millimeter, and which is equals to meter. Okay, so 100 into 1,000 will be 10,000.
10,000. Wait,
100 into
no,
100.
sir.
Yeah, it is 100 into
100
100.
into 100 is
Yeah.
10,000.
100 into 100 is 10,000. That's why centimeter has first converted into millimeter, and millimeter then converted into
How is
meter.
100?
You have that scale with you now?
So we can convert directly centimeter to meter also, right? Why it need
Yes.
to?
Yes. So we do not need to discuss that. Wait a second. Let me give you direct conversation unit. Okay, so just to remember, see here we have ones, tens, 100, 1,000 and 10,000. Okay, so 10,000 is written, you can write in this way only. It is 2, is it, what is 2? It is,
Square.
yeah, it is 2 centimeters square. It is
Okay.
given. So we had to
Yes.
convert that into meter. So we had to divide by 10,000 here. So it is ones, tens, 100, 1,000 and 10,000. Now it is going to convert into meter now. Okay. So if you will solve that, okay. So see, that point can be written as it is 10 into 10, it is 100, into 10, it is 1,000, into 10 will be 10,000, right?
10,000.
Yeah. So can we write that it is 2 divided by 10 to the power 4, because 10 into 10, 10 and 10 will be 10 to the power 4. Is it or not?
Yes.
Now I'm going to transfer that denominator into numerator. So it can be written as 2 into 10 to the power minus 4.
4.
Can we write
Yes.
that? Yeah.
Yes,
So
sir.
now we have here area. Area equals to 2 into, it is 2 into 10 to the power minus 4 meter. And we had the pressure. No, pressure is no force. What is force? It is 2 Newton, right? Now we have formula. Pressure equals to. What is pressure equals to?
Newton
Yes.
per
Area.
meter square.
Yes, it is force divided by area.
Area.
So what is force? It is 2 Newton meter.
2
It is 2
Newton
Newton.
by
Yes. Divided by area. What is area?
2 into 10 power
It
minus.
is, yes, 2 into 10 to the power minus 4. Again, we are transferring that 2 into 2 to the power minus 4 into numerator. See, whenever we are transferring things from denominator to numerator, power
This
sign
change.
will going to change. Yes. So 2 Newton divided by 2 into that part will become 10 to the power 4. So 2 1 is 2. So 1 into 10 to the power 4 will be what? 10,000. Right? So 10 to 1 into 10 to the power 4 means 10,000. So it will be 10,000 Newton meter square, and Newton meter square is nothing but Pascal. So we have the
Yes,
answer
sir.
here.
But why you need to write 10 to the power 4? You can directly write 0.002, right?
Yes, but see, for that we have to divide that again and again. But if you will write 10 to the power minus 4 or 4 here, it is going to like easy calculation. 10 to the power 4 means what? 10 into 10 into 10 into 10.
Yes, sir.
So instead of using 10,000, we can use 10 to the power 4. Okay.
Okay, sir.
So the pressure, yeah. So pressure will be 10 to 1 into 10 to the power 4 or 10,000 Newton meter square, and which is equals to Pascal. So it is 10,000 Pascal.
So what is PA?
Pascal.
Okay, sir.
Yeah. So this is all about the numerical. So if you want, you can take a screenshot for that. Done?
1 minute, sir.
Yes, sir. Then
Sir, we will do quizzes, sir, now.
We have one more